In this lesson, we're going to cover data backups. When it comes to data, our golden rule is to never put all of our eggs in one basket. And so in terms of data, we should never keep all of our data on a single device or server, otherwise it could be lost due to an accidental deletion or the system failing prematurely. To prevent our data from being inadvertently lost, it's always considered to be a best practice to maintain backups of your data, and in the case of extremely important data, you should actually create multiple backup copies of that data too. So what exactly is a data backup? Well, a data backup is the process of creating duplicate copies of digital information to protect it against data loss, corruption, or unavailability. So in this lesson, we're going to cover both on-site and off-site backups, the recommended frequency that should be used for your backups, the use of encryption in your backups, the concept of a snapshot and how it's different from a regular backup, how data recovery is going to be performed, how replication occurs, and how journaling can be used as a form of data backup too. First, let's talk about on-site and off-site backups. An on-site or off-site backup refers to a backup of your data where it's physically going to be stored in some place. Now, if you utilize on-site storage to hold your backups, this means your data will be physically located within your own data center or office environment. For example, if you conduct a full backup of your laptop to an external hard drive and then place that external hard drive in the drawer of your desk in your office, this would be considered an on-site backup of your laptop's data. While having an on-site backup can be really convenient and it works well if you need to quickly restore some of those files that were accidentally deleted from your system, it is important to remember that your backed up data might be vulnerable to destruction in the case of an environmental outage or disaster, though, if it's on-site. For example, if your office building and its equipment was destroyed due to a fire or a flood, your backups will also be destroyed because they were sitting in your desk at that facility and they were being kept as an on-site backup. So, to overcome this risk, we want to utilize off-site backups too. Now, an off-site backup refers to the practice of storing duplicate copies of data at geographically separate locations from the primary data source in order to provide you with protections against physical disasters and to ensure your data continuity. Often, these off-site backups are created using cloud-based servers, so the data is simply backed up to a remote server over the internet. Or, you can create a physical backup of the data using backup tapes or external hard drives, and then move those things physically by shipping them to a remote facility for storage. For example, I used to work as the director of a network theater security operations center for the US government during a time of war. Now, our network's data center was located within striking distance of our enemy's missiles, and therefore we provided both on-site and off-site backups. Each day, we conducted a nightly on-site backup of all of our data to removable tapes. Then, once a week, we actually shipped copies of those tapes to another facility that was located about 1,000 miles away that was outside of the range of those missiles. That way, if our facility did come under attack, all of our data would still be available for restoration at another data center using those off-site backups. Now, this was all back in the days before cloud computing and super fast internet connections. So these days instead, we wouldn't ship those tapes off, and instead, we would simply create a high-speed connection between the two locations and perform our off-site backups over the internet instead of having to physically ship all those backup tapes to the remote site each and every week. Now, the second thing we need to talk about is the frequency of our backups that we need to consider. When it comes to determining how often you need to conduct a backup, you need to ask yourself one simple question. How much data am I willing to lose? Now, if you're willing to lose a week's worth of data or a day's worth or an hour's worth, that's going to dictate your backup plans and the architecture you need to build out to support your backup strategy. As you build out your backup strategy, it's important that you consider your organization's RPO or recovery point objective. This will ensure that your backup plan will be able to maintain the amount of data required to make sure any data loss is staying underneath your organization's RPO threshold. So, if your organization is willing to only accept an hour of data being lost, then you need to ensure you're conducting backups at least one time per hour. If instead you could lose up to 2 days worth of data, you could run your backups every day or every evening instead, and that would be totally fine because you're still underneath the 2-day threshold set as the RPO threshold for your organization. Now, another consideration is how frequently your data is going to be changed inside of your business. If you change the data every day, then daily backups may be just fine. On the other hand, if you're changing a large amount of data every hour, then hourly backups or backups occurring every 30 to 45 minutes might be more appropriate for your organization. The key here is to balance your organization's need for the up-to-date backups with the amount of resources, including things like time, storage space, bandwidth, and cost that you're willing to assign to the task of performing all of these backups. Third, we need to discuss the use of encryption with your backups. Now, encryption is a fundamental safeguard that will help protect your backup data from unauthorized access and potential data breaches. By encrypting your backup files, you can ensure that even if your backup media or files do fall into the wrong hands, the data on them will remain unintelligible without the proper decryption key. Now, this ensures your sensitive information remains confidential and safe from prying eyes. Now, your backups should also use both data at rest encryption and data in transit encryption. Data at rest encryption is going to be used to encrypt the data as it's written to the storage device. Data in transit encryption, on the other hand, is going to be used to protect the data during its transmission to or from the backup destination in order to maintain the confidentiality and integrity of your backups while they're moving across your network or across your system's internal data bus. Fourth, let's explore how snapshots are going to be used as a form of data backup. Now, snapshots are point-in-time copies of your data that captures a consistent state that's going to be essentially a frozen-in-time copy of your data. Unlike traditional backups that involve copying all of your data at a specific moment, snapshots are much more efficient because they're only going to record the changes made since the previous snapshot. This efficiency not only reduces your storage requirements, but it also allows for a quicker backup process and more frequent capture of any data changes. Snapshots are particularly valuable for systems where data consistency is considered to be critical, such as inside of databases or file servers, because this will enable you to restore your data to a specific point in time to effectively roll back to a known good state in case of any kind of data corruption, accidental deletions, or other issues that might have occurred. Fifth, we need to consider how data recovery is going to be performed. Recovery is the ultimate goal of any backup strategy that's used within our organization because recovery is used to regain access to your data in the event of a data loss or a system failure. A well-defined and thoroughly tested recovery plan is essential for ensuring a swift and effective response to any unexpected data incidents. There are several key steps in the data recovery process, including the selection of the right backup, initiating the recovery process, data validation, testing and validation, documentation and reporting, and notification. Now, depending on the nature of the data loss at issue, you must first identify the appropriate backup copy to restore from. This selection may involve choosing from a snapshot, an off-site backup, or another copy on-site based on the specific circumstances of your organization. Then, once the appropriate backup copy is chosen, the recovery process will be begun by accessing the backup storage location and initiating the restoration of that data. After that, the data must be validated to verify the integrity and consistency of the restored data. This validation will ensure that the recovered data matches the expected state and hasn't been corrupted during the restoration process. In addition to data validation, testing the entire recovery process is also essential. By regularly testing your recovery procedures, you can help to identify any potential issues or bottlenecks that may arise during a real recovery scenario. Next, you must perform documentation and reporting by keeping detailed records of the recovery process for post-incident analysis and compliance purposes. Documenting the steps taken, the time required for recovery, and any challenges encountered can provide valuable insights for refining your backup and recovery strategy. Finally, depending on the nature of the incident, it may be necessary to notify relevant stakeholders, such as information technology teams, management, or your end users, about the data loss and the progress of your recovery efforts. Now, ensuring that you can effectively recover your systems using data backups is also really essential, because otherwise, your backups are going to be useless if you're not able to recover the data from them when a disaster actually occurs. This is why practicing your data recovery at least once per month is considered to be a best practice in the world of cybersecurity and information technology. Sixth, we have replication. Now, replication involves making real-time or near real-time copies of your data. Unlike backups, which are periodic in nature, replication will keep your data stored in two places simultaneously. If one server crashes, the other will be able to continue without interruption. A replication approach is a really good idea when you're architecting a high availability environment or for those who cannot afford any downtime or interruptions to their systems or their data. One of the primary benefits of using replication, though, lies in its ability to provide seamless data continuity, so keep that in mind too. Seventh, we have journaling. Now, journaling, also known as change tracking or logging, will involve maintaining a meticulous record of every change made to an organization's data over time. This comprehensive journal or log will serve as a historical account of the data modifications and will offer valuable insights to be able to enable the precise data recovery to a specific point in time if a disaster strikes. Journaling is really beneficial in scenarios which require a more granular data recovery capability, such as during a legal proceeding or a compliance audit. With a well-maintained journal, you're going to be able to track and roll back individual changes to ensure that data integrity and compliance is being maintained within the applicable regulatory standards. Journaling is a particularly valuable thing to use inside of your databases and for critical systems because it allows an organization to maintain a detailed audit trail of all of your data modifications and alterations. Journaling can be implemented effectively if you maintain a strong attention to detail, including selecting the appropriate data tracking granularity, managing the journal's size and retention policies, and ensuring its security to prevent any kind of tampering. By embracing journaling as part of your data management strategy, you not only enhance data recoverability, but you also reinforce the accountability and transparency in your data handling practices. So remember, data backups aren't just about copying your organization's data, but they're also focused instead on creating a robust, multi-layered strategy to combat any potential data loss. Data backup plans are created by mixing and matching different techniques, including on-site and off-site storage, setting the right frequency, encrypting your sensitive data, using snapshots, planning your recovery, and maybe even incorporating replication and journaling into your organization's backup strategy. By understanding and implementing these concepts, you're not just backing up data, but you're also securing your business's continuity and integrity well into the future. After all, in today's modern digital environments, there is nothing more valuable than your organization's data.